Welcome to a course on application security. The course will highlight the features and characteristics of both secure and insecure applications and examine the most widespread types of application layer attacks. To start off, a secure application is an application that above all must be able to deal with atypical, unexpected, or incorrect input efficiently. The most common types of attacks, including buffer overflow, SQL injection, or HTML cross-site scripting, rely on the insecure input handling of non-typical, incorrect, or specially crafted input. How did this problem come about? The picture above is an illustration of an obviously great construction achievement. Erecting the bridge did not only require detailed planning, but also putting the plans into action. It required the ability to predict all possible scenarios and circumstances and potential problems. The result is an impressive bridge that feels and is safe. What it means for us is that creating safe solutions is possible regardless of scale. Unfortunately, though, constructing a faultless bridge, even as large as the one in the picture, is less demanding than writing a secure application. It's easy to foresee the external threats a bridge will come up against in its use. It's wind and water. The factors can be provided for during design, and the completed design will only need to be followed exactly. Applications, on the other hand, have to be immune against unforeseen factors and threats, against unexpected exploitation attempts launched by knowledgeable attackers. The scale of the problem is altogether different. We could write an application that doesn't act up if all allowed input would be in the specified range or would be valid. Creating an application that is secure per se is far less easy. A secure application's default settings should be, at once, the safest options. The rationale for this is that the majority of users don't change the configuration after they've installed an application. Especially, features that aren't used on a daily basis will rarely be disabled. If the features aren't being used or worked with, this usually means that a user is not aware of them. Disabling features that you don't know exist is rather tricky. If an application's default configuration is the most functional, you face the risk that it would run in a much wider range than the tasks it's usually made to. And the range you can't see is the range you can't protect. A secure application is an application that doesn't need escalated or superfluous permissions to run. Administrative permissions in particular should not be required. These rules are the principle of least privilege and the principle of minimizing attack surface areas. They both work to reduce fallout from a potential attack. If an application runs under a standard user's permissions, all changes that can be made will only apply to the user's session. The next step would be to adopt a model that is popular in the Linux and Unix environments. Escalated permissions are not necessary there not only to run an application but also to install it. An application would be installed per user, and the user would be held responsible for it. Carnegie Mellon research shows that for every 10,000 lines of code, there are from 15 to 30 programming bugs. About 5% of the bugs are security critical, affecting the security of the application or indirectly the security of the system and users. This means that if a program contains 10 million lines of code, it will have 20,000 bugs on average. 1,000 of them may have a bearing on the application's security. That's quite a large number. If we were able to create a truly secure application, it would have to be flawless. As you can see, though, this is nearly impossible. If an attacker spots and exploits just one of the 1,000 vulnerabilities, they'll take over the application. Of course, this depends on the permissions that it runs under and how critical the bug was. Application security is especially vital in view of the fact that in 2005, the number of detected system holes, the bugs that are security critical, dropped lower than 10% of all identified vulnerabilities. This means that application bugs account for 90% of all vulnerabilities. Administrators and users, possibly out of habit, usually spend most of their time on protecting operating systems. It can be said that 90% of an administrator's working hours are spent on eliminating threats that are less than 10% of all applicable hazards. What makes things even worse is that application layer attacks succeed regardless of any security solutions implemented in the system or network layers. The attacks don't modify network packages in ways that are not provided for by protocols. They don't scan any ports. That's why firewalls and intrusion detection systems are easy to bypass. An application attack is indistinguishable from normal usage for a computer network. Apart from that, an application is run directly by a user. And since it's a user who's run it, a system can't disable it from performing any operations. It was the user's informed decision to run the program. The system will not control it from then on. We're ignoring the solutions that are less popular today, like permissions that are granted to code or application and not to user. In a context of a user's session, an application is free to do anything. We'll try to answer some interesting questions in this module. What's the typical schema for a buffer overflow attack? Why is modifying or controlling program execution possible without modifying the program's source code? Why are databases vulnerable to SQL injection, SQL query manipulation attacks? Can these database servers and database application attacks be automated? Why does a cross-site scripting attack target a page's visitors and not the web page itself? How can an attacker impersonate an authenticated user of a web application? Finally, we'll try to see if there's some way to prevent users from running insecure or harmful programs. We'll also discuss the features and characteristics of insecure programs. See you in the training.